Microbial limits and criteria. This is the module on microbiological testing of foods, and this lecture covers microbiological limits and criteria. This presentation aims to aid in the understanding of the type of information needed for establishing microbial criteria. Also aims to assist in finding sources of validated analytical methods and to define the importance of units and limits of detection for these methods. Finally, we will define the difference between microbiological standards, specifications, and guidelines. One of the questions that always arises is, what is an acceptable level for these microbiological tests in my product? Unfortunately, establishing this microbial limit without associated methods and sampling plans is a frivolous endeavor. A test method must be matched to your food type. In addition, you have to determine where you will be sampling and the frequency at which that sampling will occur. Finally, you must establish what happens if you have a failing test result. For example, if we have an aerobic plate count above our microbial limit on a clean and sanitized food contact surface, this may result in re-cleaning and sanitizing that surface before product is run on that line. Or, if we have a positive indicator test post-processing in our final product, this may initiate reprocessing or rework on this product. When we have microbiological limits that include the sampling plan, analytical procedures, and define the action or decision based on the results, this is termed microbial criteria. Therefore, the question we should be asking is, how can I establish the microbial criteria for my product? When establishing your microbial criteria, you want to make sure to include the type of sample you are collecting, for example, an environmental swab or X grams of a product, and the number of samples you will be collecting. You would also include the location for environmental sampling. The analytical method must be included and needs to be a scientifically validated method. You, as a processor, must establish how many of your test results must fall within the limit you have set for the specific microbial test. For example, if you are using aerobic plate count to verify cleaning and sanitation for a food contact surface, you might set a threshold of less than 500 colony-forming units per mil as acceptable. You may also establish that 90% of your samples must conform to this limit. So if you collect 10 samples, one of those samples can have an aerobic plate count above 500 colony-forming units per mil, and you will still have an acceptable result for your microbial criteria for cleaning and sanitizing this surface. You establish these criteria for both microbial quality and safety reasons, and microbial criteria are also important due to regulations and buyer requirements. Determining the appropriate test or analytical method is very important. As previously mentioned, the analytical method of choice must be validated for the target organism and food type. A method developed for one food type may not work in a different food matrix. There are several sources of validated methods, including ISO, BAM, APHA, and others. A critical factor to understand when reporting and interpreting microbial test results is the unit in which the result is reported. Common units include CFU, or colony-forming unit, per X number of grams or X number of milliliters, and also most probable number, or MPN, per X number of grams or X number of milliliters. Other tests may simply give you a presence or absence result. Certain regulations may have specific units in which they require results to be reported, so make sure that you understand these requirements if they apply to your product. Also understand that each analytical method has a limit of detection or a level of microorganisms below which the test will be negative even though the microorganism is present. This means that there is never a true zero test result. Some results will be reported as below detection limit, often the case if the test is quantitative. Remember, a negative does not mean zero. It could just be that there is none of the target organism in the sample, or just that the level of the target is below the detection limit. Now we will get into some of the terminology related to microbial testing. Note that these terms are often used interchangeably in many situations. Microbial standards refer to regulations that define a microbial limit. A microbial specification is a microbial limit that is set between a vendor and a buyer. Microbial guidelines are often set internally by a processor or are established by a specific industry. Microbiological standards in the United States are established by the FDA and USDA for specific high-risk food types. Exceeding an FDA or USDA microbiological standard will require a recall. These are essentially the legal acceptance criteria for your product to enter commerce in the United States. Many of these microbiological standards are zero tolerance for pathogens. Examples include Shiga toxin-producing E. coli in beef and any pathogen in a ready-to-eat food. This means if you have a positive test result for these pathogens in these products that you must recall. Microbial specifications are microbial limits set between a buyer and a supplier. As I'm sure you're all aware, failure to meet your buyer requirements can lead to product rejection and potentially loss of that buyer. Again, these microbiological specifications are going to be dependent on the product and the type of processing. For example, pasteurized or cooked products typically have microbial specifications that are low for aerobic plate count, Enterobacteriaceae or coliforms, lactic acid bacteria, yeast, and mold. Ready-to-eat fermented foods typically do not have microbial specifications for aerobic plate count or lactic acid bacteria. We would expect high levels, but Enterobacteriaceae, coliforms, yeasts, and molds should be low in these products. In dried, ready-to-eat products such as spices, aerobic plate count, lactic acid bacteria, yeasts, and molds will be higher due to the processing methods. However, Enterobacteriaceae and coliforms should still be relatively low in these types of products. Specifications for raw products, such as produce, are rare, but some exceptions exist. Overall, the buyer's needs drive the specification limits. Lower microbial load ingredients may drive a higher price. The microbial load can also drive a buyer to select one lot of product over another. Microbial guidelines are internal acceptance criteria established by a processor or trade organization. For example, yogurt has a requirement established by the National Yogurt Association for labeling a yogurt product as contains live and active cultures. This microbial guideline for yogurt is 100 million active cultures per gram of yogurt. In summary, microbial criteria include microbial limits, sampling plans, analytical methods, and are used to determine product acceptance. Analytical methods must be matched to the target organisms and the product. Microbiological standards are legal acceptance criteria. Microbiological specifications are set between a buyer and a supplier. Microbiological guidelines are internal acceptance criteria.